Hello, this is Dr. Janet Six, Senior Product Manager at Tom Sawyer Software, and today we're going to talk about how to create, build, and deploy a graph visualization application with Perspectives. Tom Sawyer Perspectives is an SDK and low-code graph visualization and analysis development platform with integrated design and preview interfaces and extensive API libraries that allow developers to quickly create custom applications that intuitively solve big data problems. We open Perspectives Designer with an empty project. First thing that we do is to add a module. A module contains one schema describing the data, integrators, drawing templates, visualization views, search, filter, and analysis configurations, along with a view layout. Next step is to add the integrator. So we'll select Integrator, Add Integrator, and then we're going to choose TinkerPop for this example. Here we're going to enter our server address, and then we're going to update the serializer, and let's test our data source. Next, we're going to choose the graph or the partition of the graph database we want to connect to. And we're going to automatically extract the schema for our application. You can see that 5 element types were added to the schema here. Next, we're going to bind data into our model with a query. So we enter a Gremlin query to bring in 75 elements and select the preview of the data, which you can see here. And now our data model is populated. If we wanted to update the appearance of our nodes or edges in the drawing view, we would do that here in the drawing templates. Or if we wanted to add graph analysis, we would do that here in the analyzers. Today we're going to go directly into creating our data visualization views. First, we're going to create a drawing view. So we're going to select the All Vertices and All Edges domains and click OK. And now, for every vertex that we have in the model, we're going to create a node in our drawing view. So we're going to right-click, choose Structural and Add Node, and we'll take the defaults for the ID and the template. And then we're going to repeat with the edges. If there's an edge in the model, then we're going to add an edge in our drawing view. And again, we can take the defaults for the edge, source, and target IDs as well as the template. We'll click OK. And now our drawing view is complete. Next, we're going to add a tree view to our application. So we're going to select Tree, and then click OK, and select the All Vertices domain. So for every vertex that we have in the model, we're now going to add a tree node in our tree view. We're going to take the default for the tree node ID, and for the parent tree node ID, we're going to choose the root because we want all of the tree nodes to be in a single tree. Now we're going to choose the value that's going to show in the tree. So we're going to open our expression builder. And here you're going to see those elements which were automatically extracted into our schema while we were setting up the integrator. And we're going to select Name to show in the tree. We click OK, and now the tree node is fully defined. And for each vertex that we have in the model, we will have an item in the tree. Now we're going to sort the children in the tree. We select Root Tree Node because all the items are in a single list. And we're going to sort the items into ascending order by attribute, specifically the name attribute. And our tree view is fully defined. Now we're going to add a table view. So we're going to select Table and click OK. And here we're going to choose the songs because that's what we want in our table. And now we're going to choose the attributes that we want to show in the table. In this case, we're going to choose all of the attributes. We click OK, and now our table view is fully defined. Next, we're going to add an inspector view. So we're going to add View, choose Inspector, and click OK. We select the All Elements domain so that the inspector will show attributes for any node or edge that is selected. And we click OK. Now we're going to select Include Attributes Dynamically. With dynamic attribute inclusion, the attributes are automatically detected when a user selects one or more elements in another view, and then those attributes are shown in the inspector. This feature is especially useful if all attributes are not known at design time. And we click OK. The inspector view is now fully defined. Now that we've defined all of our data visualization views, we're going to go and create our dashboard. So we're going to go to View Layout and add our data visualization views. First, we're going to add the drawing view. So we're going to select it, and there it is. Now we're going to add a horizontal split panel to make room for our tree view. So we're going to click the plus sign and add our tree view. That's a lot of space for the tree view, so we're going to drag over the split panel so the tree view doesn't take as much space. Next, we're going to add a vertical split panel to make room for our inspector. So we click the plus sign, and now we add the inspector view. We're going to resize that panel as well. And finally, we're going to add our table view. So we're going to add a vertical split panel, and we're going to add the table view. And there is our dashboard, fully defined. And now that we have our dashboard, it's time to build our application. We are going to use the Generate Web Application Code button in order to generate the files needed to compile and run a Perspectives application, or to package it for deployment to a web server. In this dialog, we're going to enter the project ID, which is the output folder name, Maven artifact ID, and jar name. In this case, we're going to use video example. The group ID specifies the Maven artifact coordinates and Java package to be created. We are going to stay with the default here. And the output folder is the location for the generated application code. We are going to keep the default here as well. And we click OK. And now we see that the web application code has been successfully generated. Let's go take a look. And here in the application folder, we see all of the files that we just generated. We're going to open the README file, which is going to tell us what we need to do next. It's time for us to build the application, so we're going to go to that part of the README file. We're going to select the Maven command, and we're going to copy it. And then we're going to go and open a terminal at the application folder. And here we're going to enter the build command that we just copied from the README file. And we can see the build has completed successfully. It's time to deploy the application. When we generated the web application code, we also created deployment files and scripts for Docker, Kubernetes, and AWS Terraform. Today, we're going to deploy to Docker running locally. We're going to open the README file, which is going to tell us what we need to do next. And we can see in Docker Desktop that we currently do not have any running containers. And we return to the README file to copy the next command that we need to deploy the application. We're going to open a terminal at our Docker folder, and we're going to enter the command that we just copied from the README file. Then we go and get the next command to run our deployment script. We'll need to enter the password in order to perform the sudo command. And the application is now successfully deployed in Docker. So we're going to copy the URL so we can go and see the application running. And you can see the container running in Docker Desktop as well. Let's go use the application. So I'm going to open the web browser and enter the URL that we copied a moment ago. And here is our application running. We can select a node in our drawing view, and you'll see that same element highlighted in our tree view, the attributes down here in our inspector view, and the same element highlighted in our table view. Now we're going to apply different layout styles to our graph. First, we apply hierarchical layout, which emphasizes dependency, relationships, and flows. Next, we apply bundle layout, which intelligently combines or bundles related edges so that we can usefully lay out larger, more complex graphs in a smaller space. We apply circular layout to emphasize clusters which naturally occur in the topology of the graph. Next, we apply orthogonal layout, which routes edges primarily with horizontal and vertical edge segments. And we apply symmetric layout to highlight natural symmetries in the graph. In today's video, we discussed how to start with an empty project, integrate with a database, create a dashboard with several data visualization views, and deploy the application in minutes. You can find more information about integration with different types of data sources, creation of views, generating web application code, application deployment, and more on our YouTube channel. Thanks for joining us. Contact Tom Sawyer Software today to start your free trial of Tom Sawyer Perspectives.